Yesterday, we followed up your hat activity and we talked a little bit about this idea of a transformation, which is moving a shape around. And we introduced some vocabulary and we said that there's four types of transformations. A translation, which is a slide, and that's what we focused a little more on yesterday. A dilation, which changes the size. So in your hat activity, you saw translations and dilations. So you got a little introduction to how those work. We also said that there's a couple of others. There's the reflection, which is a flip, and a rotation, which is spinning a shape. What we're going to focus on today is a little bit about reflections and thinking about how reflection works and how that connects to shapes, polygons, because we've been talking about polygons in this unit. We actually are not going to talk about rotations in this unit because rotations are much trickier. That's something that most of you will loop back to and talk more about next year when we talk more about this and build on it. But what we're going to do today is we're going to introduce a little bit about reflections because that involves some things with polygons that we've been talking about. So shapes can have something that is called symmetry. If a shape could be folded onto itself, or in other words, if it can be flipped onto itself. So you have to think of a fold as kind of like a flip, flipping part of the shape over onto the other part of the shape. So that's called symmetry. So those fold lines where you can fold the shape and flip one half onto the other half, those are called, each fold line is called a line of symmetry. So some shapes can be flipped onto themselves and some shapes cannot. So if a shape can be folded or flipped onto itself, then we say it has symmetry. And if it can't, then we say it doesn't have symmetry. So these are a couple of examples. So this is a rectangle. So a rectangle has a couple of different fold lines. And this is a rough sketch, so it might not be exact, but you get the idea. So we could take a full rectangle, we could put a fold line right there, and we could fold it in half left to right. I know my line's not right in the center, but you get the idea. So you could fold the rectangle that way. You could also fold the rectangle up and down. So this rectangle actually has two different lines of symmetry. You could not fold it diagonal. If you tried to fold it diagonal, this corner would end up here, not on top of the other corner. So diagonal fold does not work with the rectangle. But you can fold it left to right or up and down. So does the shape have symmetry? We would say for a rectangle, yes, it does, because it has those fold lines. We can flip it onto itself. This other guy, this is just a generic kind of funky looking quadrilateral. No matter which way we try and fold this, because this piece is really little and this piece is a lot bigger, there's not going to be any way to get this shape to flip onto itself. So this one we would say doesn't have any symmetry because there's no fold lines. There's no way to flip the shape and have it fit perfectly on top of each other. So symmetry is reflecting a shape onto itself. So when we look for those fold lines, we're basically flipping a shape onto itself. So symmetry is a type of reflection, which connects with our polygons and our shapes that we've been using, because shapes can have symmetry. Shapes can be reflected onto themselves as a property of some shapes. So you can reflect a shape onto itself, and when you do that, we call it symmetry. We can also take the entire shape and reflect it over an external line. Then it would just be a generic reflection. And I want to think about or show you how that works. So it's one type of reflection is a symmetry, where you're folding a shape onto itself. Another type of reflection would be a general reflection, where you've got a line that's not on the shape anywhere. It's off someplace else. So when you're reflecting over an external line, a graph is a really nice way to keep track of what things are going, where things are going, where your shape lands. So you're going to try doing some reflecting on a graph today. So this one, it says, reflect the following shape over the y-axis. So I'm actually going to highlight the y-axis. So the y-axis is right there. So that's kind of like our fold line. But notice that it's not running through the shape. So we're not going to be folding the shape onto itself. We're going to be basically, if you think of kind of folding the entire graph along that line, you have to think of where the shape would land. So if I folded this entire graph, like if I had literally cut this out on a piece of paper and I folded it over, everything over here would flip over onto that side of the graph. So what's going to happen if this is my fold line is my shape is going to end up right here. So if you imagine literally folding the paper in half, that's where your shape would be sitting if you took the right side and folded it over onto the left side. So hopefully you can kind of visualize that folding it over. Because a reflection is like a flip, or a fold is another way to think of a flip. So a couple things I want to point out about this. So this is where it lands if you think about literally folding the graph over onto itself. So you still got this idea of flipping or folding. We're just not flipping or folding the shape onto itself. We're folding it somewhere else. When you reflect over an external line, one thing I want to point out is this was 2 units away from the line. And when we fold it over, it's still 2 units away from the line. So that's a good way to know, okay, if I'm flipping this over an outside line, is my shape landing in the same spot? So it should stay the same distance away from the line. So this line that we're flipping over is called, because it's not a line of symmetry, because symmetry runs through the middle of a shape. So this would be called a line of reflection. So when you're not going or not folding a shape onto itself, then you're working with a line of reflection. So when you fold a shape over a line of reflection, one property of that and a way to check your work and see if you're right is that that shape should still be the same distance from your fold line or the line of reflection. So that's a good just kind of check your work or check your work strategy. So shape stays the same distance from the line of reflection. So if I had wanted to, I could have reflected this the other way too. So this problem has to reflect over the y-axis. If I really wanted to, I could reflect this over the x-axis. I could put my fold line right there. If I put my fold line right there, if I folded this side of the graph onto the other side of the graph, my shape would end up right there. So you can fold, flip, reflect, all the same thing, different words for the same thing. You can reflect on a graph over the y-axis or over the x-axis. Those are kind of natural fold points or lines of reflection. So this problem didn't actually ask you to go over the x-axis or to fold it over the x-axis like that, but I just wanted to show you that you can do that, because you'll have some problems where you'll get to give that a try. So that gives you kind of an introduction to another one of our transformations. So we've worked a little bit with translations yesterday. You got a little bit of an introduction to dilation, changing the size of something in the hat activity. And now we're going to do a little bit of work with reflections. So what you're going to do today, since we talked about 2 different types of reflections, so symmetry, which is folding a shape onto itself, and then reflection over a line that's not running through the shape, you're going to try both of these reflections. So you're going to have some assignment today. You're going to have some problems, and you're going to have to figure out, does the shape have symmetry? Can it fold or reflect onto itself? And then you also have some shapes that you're going to put on a graph, and you're going to try flipping them or reflecting them over the x-axis or the y-axis and folding them over that way. So when you are ready, you are going to go ahead and try today's assignment.